So let's take a look at Pascal's triangle and binomial expansion. In Pascal's triangle, the first and last numbers in each row are 1. Each number other than 1 is the sum of the closest two numbers of the row directly above it. The number in Pascal's triangle are the same numbers that are the coefficients of binomial expansion as shown in the first 6 rows. Now again, it's saying 6 rows because our first row is actually row 0. Okay? And so that is a plus b raised to the 0 power. Remember that anything raised to the 0 power is 1. So in Pascal's triangle, that is the 1 at the top. Then let's look at degree 1. A plus b raised to the first power. Now you see that's just 1a plus 1b, which is the 1, 1. Then look at row 2. That's a plus b, and that's squared. So we should know that pattern. This is 1a squared plus 2ab plus b squared, 1b squared. Remember with Pascal triangle, you have 1, then you add the two numbers above, 1 plus 1, that is our 2, and the last one is 1. So notice the coefficients correspond. Let's look at the third power, a plus b cubed. And remember the numbers for that. So this is a 1, it always starts with 1. 1 plus 2 is 3. 2 plus 1 is also 3. And then we have our last number, which is 1. So those are our coefficients. So we start with 1, and then we start with the a cubed first. A cubed plus 3, a squared b, plus 3ab squared, plus 1b cubed. So there's lots of things to notice. There are so many patterns in here that you can see. One pattern that a student pointed out is that whatever the power is, so we're in the third power, that is the first number here after the 1, so that does seem to correspond. Another thing to notice is that the powers decrease. So if we're looking at a, notice it's a cubed, then a squared, a to the first, and a to the 0. Remember, a to the 0 is just 1. Now if we look at the second term, b, just imagine a b to the 0 here. B to the 0 is just 1. Then it's b to the first, b to the second, b to the third. So it increases, so the a is decrease in exponents, the b increase as you go from left to right. And then just even one more thing that I want you to notice, because that's one thing that really helps me out when I'm trying to use binomial expansion, is that the exponents, the sum of the exponents in each term are the number of the actual row. So if we're in row 3, notice that the exponent is 3, and there's no other exponent, right? And then this exponent is 2, and then this is really a b to the first power, right, which is 3. This is a to the first power, plus 2 is also 3, and this is 3. Let's see if it holds true in our fourth row. So this is 4. Let's look at the fourth row. A plus b to the fourth power. Let's do Pascal's triangle. So the first number is 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, and the last one 3, and then the last one is just 1. So we start with a to the fourth plus, the first number is 4, a to the third power, and then b to the first, plus 6, a squared b squared, plus 4, ab cubed, plus 1b to the fourth power. So just kind of taking a look at what I noted before, that the sum of the exponents, right, if you were to add the exponents, this is 4. Then this one, a cubed plus 1 is 4. This is a squared plus b squared, that is 4 if I added it together. A to the first, b to the third, that's 4, and b to the fourth. So that's really helpful. I know when I'm writing my binomial expansion out, I know that it decreases, and so I know what to write for the first term, and then for my b term, if it's, first power or second power. Let's look at the fifth row. This is a, b to the fifth. So our numbers are 1, 5, 10, 10, 5, 1. So this is 1a to the fifth plus 5a fourth to the b plus 10a cubed b squared plus 10a squared b cubed plus 5ab to the fourth plus 1b to the fifth power. And I go back and check if I did it correctly. So I have 1, 5, 10, 10, 5, 1. This is 5, 4, 3, 2, 1, none, and then 0, 1, 2, 3, 4, 5. So these are our rows. So let's use that to expand binomials. So if you notice that, yes, this is harder conceptually. It is. But I don't want to multiply this out because you realize that if you do that, that's x minus 2 5 times. It would probably take me this entire page, right? I only have a little space. And so it does save time. Yes, it is hard to learn. It is something new. But if you can learn the pattern, it is very useful. So let's try it. We're looking at x minus 2 to the 5th power. So we're looking at the 5th row. So the power tells us where we look at. We look at the 5th row, and so we plug it in. We know that a is x, b is negative 2. So we have a to the 5th. So that's x to the 5th power plus, and then the coefficient of 5, times a to the 4th. So x to the 4th times negative 2. And then plus 10x cubed, and then negative 2 squared, plus 10x squared times negative 2 to the 3rd power, plus 5 times x times negative 2 to the 4th power, plus negative 2 to the 5th power. So to make sure that I have everything, I double check. So x to the 5th, 5, 10, 10, 5, and then our b to the 5th. And look at my exponents. So x to the 5th, 4th, 3rd, squared, 1, and then gone. And then for b's, I have negative 2 to the 1st, 2nd, 3rd, 4th, and 5th. So I have everything there. So now I just need to multiply the numbers. So in the first one, that's just x to the 5th, so that's fine. And then we have negative 2 times positive 5. That becomes negative 10, x to the 4th. Then we look at the next one. So remember the exponent first. Negative 2 squared, that's a positive 4. 4 times 10 is positive 40, x cubed. Now the next term, we have negative 2 to the 3rd power. That is negative 8 times a positive 10, which is negative 80, x squared. Then we have 2 to the 4th power. So I think about that as 2 times 2 times 2 times 2. So 4 times 4 is 16. And then 16 times 5, 16 times 5, that is a positive 80x. Then negative 2 to the 5th power, so it's odd. So that means I keep my negative, that is negative 32. So that is the final answer. Now, yes, I know that is hard, but that is much shorter than trying to multiply this out several times. You would probably end up with like a 4 by $5, and that would take quite some time to multiply through. Notice that the signs alternate. So if it's a negative, the negatives apply to when b is odd. Okay, b to the odd power. So for example here, negative 2 to the 1st is going to keep the negative. Negative 2 to the 3rd power will keep it a negative. And then also negative 2 to the 5th power is also negative. So that might help you out. Also knowing that it alternates each and every time. And then another thing to note is that this answer is not x to the 5th minus 32, right? That is far from that. So be careful with that. So see what you can try out. Go ahead and try these next examples below just to get some practice. Okay, if you tried this out, for letter A, we did that one together. Letter B, you should have gotten 27y cubed plus 27y plus 9y plus 1. For the example 1, x minus 3 to the 4th power, you should have x to the 4th minus 12x cubed plus 54x squared minus 108x plus 81. For number 2, for 2y plus 4 to the all raised to the 3rd power, you'd have 8y cubed plus 48y squared plus 96y plus 64.